Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's look at the second part of our homework for lesson 8.2.3. Here we've got some numbers that are written in standard form, and we need to convert these numbers into scientific notation. So the process begins with us identifying the leading digit. And then we have to identify what place the leading digit is in. Then we need to convert that place into a power of 10. So 500 or 5,467, the 5 is in the thousands place, and since 1,000 has 3 zeros, that is 10 to the third power. So if I rewrite it, I can write it as 5.4678 times 10 to the third, but what we sometimes do is we sometimes round off that leading factor so it has only 2 decimal places. Makes it a little bit easier, because really, what's the point of rewriting it in standard or in scientific notation if it's going to be all of the digits plus that additional power of 10? Here, the leading non-zero digit, I should say. Here it's a leading digit, but when you got here, the leading digit would always be 0. So we want the first non-zero digit is a 3, and it's in the hundreds. No, it's not. That's the thousands place, which is the third decimal place. So it's 10 to the negative third. 3.2 times 10 to the negative third. And then the 8 here is in the millions place, and a million is 10 to the 6th because it has 6 zeros. So it becomes 8.00702 times 10 to the 6th, but I would probably just write that as 8 times 10 to the 6th, rounding this off. All right, exponent rules. When you're dealing with fractions, you can either expand it out and cancel out all the giant ones, and you're left with 5 threes being repeatedly multiplied in the denominator, so it's 1 over 3 to the 5th, or you could use the rules for dividing powers and say 3 to the 5th divided by 3 to the 10th. We're going to keep our base, which is the 3, and 5 minus 10 is negative 5. These two are equivalent to each other. One of them uses positive exponents and a fraction. The other uses a negative exponent, but they both mean the exact same thing. Here, we're going to have to use a sequence of rules where the exponent only applies to what it touches, and oh my goodness, well, I guess this is okay. Let me expand it out a little bit right in here. So we're going to have 10 times x to the 4th, right? And then this, since the negative 2 applies to both of those, this is the power of a product, which means we're going to make that 10 to the negative 2nd power and times x to the negative 2nd power. So now let's go ahead and put all of the powers of 10 together and then all of the powers of x together. We're multiplying powers, so this is 10 to the 1st times 10 to the negative 2nd. So we're going to keep our base and add our exponents together, and it becomes 10 to the negative 1st. Here it's x to the 4th times x to the negative 2nd. So we're going to keep our base and add 4 and negative 2 to give you positive 2. So you could either write it this way, with the negative exponent for the 10, or if you had wanted to move this guy across the street and change that to a fraction, it would become 1 over 10 times x squared over 1, which is how we get it in that form. So either one of those is acceptable. Here, it's probably just better to expand it out. You got 1/4 times 1/4 times 1/4. And then 4 to the 2nd power is 4 over 1 times 4 over 1. So we end up with giant 1. You're left with 1/4 as your answer. Or if you had done work a slightly different way, you might have seen that as 4 to the negative 1st power. But I would expect most of you would get 1/4 as your answer. And then our last example. The exponent applies to whatever it touches. So this is literally x to the 3rd times y to the 3rd in the numerator. And in the denominator, the 3 is only touching the y, so it's x to the 1st times y to the 3rd. So we can see that those guys cancel each other out completely. Any number divided by itself is going to form a giant 1. But here, you've got 3 x's repeatedly multiplied across the top and 1 across the bottom. So you would have one of them would cancel out, but let's just use the exponent rules. When you're dividing powers that have the same base, you subtract the exponents. 3 minus 1 is 2. And that's what you would get if you had expanded this out and canceled out the common factors. You'd be left with x squared in the numerator. So that's your final answer. Oh, goodness gracious. I wonder how many students did all of these problems. I'm hoping at least a couple did. I'm not going to go through and work through all these, otherwise we're going to have a 30-minute video. I'm just going to say, if you are struggling with this, you can ask me to help you on any one of these problems, and I will work it out with you, okay? But here are the answers. I would recommend, before you contact me, look at your work to see where you might have made your mistakes and check to see if you've got the same answers as me. All right, relative frequency tables. Athletes in the Middle Plains School District regularly receive personal advice for their nutrition. Coaches wondered if the nutritional advising was having an impact, so they divided athletes into two groups. One group received the advice and one did not. After 6 months, they collected the following data. Why do I feel like it doesn't matter how much you talk to these kids, your advice is never going to get followed? They're just going to do what they want to do? I don't know. Maybe it's because I'm a parent. Or that I've been teaching for 23 some years or longer. If you're watching this video in the year 2050, I've been teaching and retired for a long time. Okay, so what do we need to do here? It says number of athletes. All right, so regularly ate a balanced breakfast and often did not eat a balanced breakfast. So let's check and see what the percents are. We're going to have whether they received the nutritional advice as the independent variable. So we're trying to see how that affected their eating habits. So the total number of students that received nutritional advice was 135, because that's 46 plus 89, and the number of students that did not receive the advice was 112, 39 plus 73. So if 46 out of the 135 students that received nutritional advice regularly ate a balanced breakfast, that means that 34% of the students that received this advice followed the advice and ate a balanced breakfast, whereas 89 out of 135, or 66%, chose not to eat a balanced breakfast, even though they received nutritional advice that said you should always eat a balanced breakfast. Now let's look at this data over here. Of the people who did not receive any nutritional advice, 39 out of the 112 ate a balanced breakfast, and the remaining of them did not. Now, this is not what we would expect at all. A higher percent of the students that received no advice at all actually followed the good advice and ate a balanced breakfast regularly. So the fact that there is absolutely no change, or very little change, we're going to say that there does not appear to be any association between teachers spending all that extra time, or is this coaches? I don't know if they're coaches or if they're the teachers that are giving the advice to the athletes. But at any rate, spend all that time creating these wonderful lessons for the students, and they're like, nah, I'm going to eat what I'm going to eat regardless. I don't care what they say. So, yeah, typical. All right. Oh, and I'm getting to the point where I'm hating all these because it takes so much time to graph. It says graph these points. X is at negative 3, 5, Y is at negative 2, 3, and Z is at negative 1, 4. Connect them. And that's what I did for the red triangle. Then A says reflect this across the Y-axis. So remember, when you reflect across the Y-axis, the X values change to their opposite, but the Y changes. No, say it again. I think I'm getting tired. This is like my 8th video today. All right. The X values change to their opposites, and the Y values stay the same. So here, this guy changes to its opposite. So you notice all of those ordered pairs here. This changed to a 3, this changed to a 2, this changed to a 1, but all the Y values stayed the same. Then it says translate the original. So we're going back to the red. This guy right there, translate it 6 units down, which means the Y values are going to decrease by 6, and 3 units to the right, which means the Y values are going to increase by 3. So the purple one Every one of these points is 1, 2, 3, 4, 5, 6 down, but 3 to the right. Same for all of them. And then the last one is in green. Dilate the original figure by multiplying each coordinate by -1. So not only are you reflecting over the x-axis, or over the y-axis, but also the x-axis, because both the x and the y are being multiplied times -1. All right, so there we go. Is this the end? No, we got one more. Or is it two more? One more. This is it. The table below shows the amount of money Francis had in his bank account each day since he started his new job. Notice that it's increasing by a constant rate. It's going up by $43 per day on the job. So that implies that y equals mx plus b is going to be the rule, because this is linear growth or a constant growth rate. And the growth rate is the slope of the line, so that's the 43 here, and the starting amount is your y-intercept, which goes right here. So y equals 43x plus 27. So when will Francis have more than $1,000 in his account? So how do we figure that out? Let's go ahead and solve y is equal to 43x plus 27. Since y represents the total amount of dollars, let's change that to be 1,000. So we will take away $27, and we get $973 is equal to 43x. So remember, he started with $27 in his account. He's increasing it by $43 per day. So he doesn't need to make $1,000. He only needs to make $973 because he already had 27 in there. So how many days will it take before he gets $973 increased into that account? Well, take 973, divide it by 43, and you get 22.62, 22.6. Well, that means it's between 22 and 23 days. But since in 22 days he will not have 1,000, it'll be on the 23rd day when it'll have just a little bit more than 1,000. And let's see what that would be. 43 times 23 is 989, plus the 27 that he started with means that on the 23rd day he would have $1,016. And that is it for our homework. Hooray! Let's move on to the next activity. Bye.
Hey, feeling good, like I should. When in dark, walk around the neighborhood.